Everybody, today solving class. Consider a problem. This problem takes an employee value proposition in VP. Short. It's about defining the essence of a company. The EVP is the value an employee receives. Define the commitment the company will make to develop the employee in exchange for the effort the employee puts into benefit the company. But you all agree on what makes a unique and compiling EVP. Study shows that 12% of business executives, 35% of HR leaders, 35% of employees say that compensations, that is pay and rewards, makes for a unique compelling EVP. Here we consider 100 individuals within each business group, and the claim is there is a significant difference among business. But here the business groups are first group is BE. This stands for business executive, which is 12%. Next, next for it, that is HR, which is 35% says that compensation makes for a unique and compelling EVP. And third and last group, that is the employee, we denote this by capital E. In 35% of this group says that compensation makes for unique and compelling EVP. So the responses are yes and no type. And question is whether the compensation makes unique and compelling EVP. Somebody say yes, somebody say no. In our way, in group B, we see that 12% of total samples in B group say yes. Similarly, total samples in HR group, among the samples in HR group, 35% say yes. Similarly, last employee group, 35% say yes. That compensation makes for unique. So, and since we consider 100 individuals for each groups, so if you convert this percentage into the numbers of frequency, then the observed frequency look like. So this is the group. This is the group. T group B, HR, The responses are yes, no. Question is compensation. The question is compensation makes unique compelling area. Right, it is here. Compensation makes for a unique. That's right. So since for each group, the marginal total, we consider only 100 individual, that is the each group size, sample size should be 100. Since in group B, 12% say yes, that means the frequency of yes is 12 in the group. We consider 100 samples, individuals in each population. Okay, each group. So they know is remaining part, that is 100 minus 12, that is 18. Okay. Again, 35% say yes in HR group, that, and we consider 100 individuals in HR group. So 35 say yes in HR group, and remaining part, that is 100 minus 35, say no for HR. Similarly, for employee group, 35% say yes. That means sequence of yes is 35 in group, and rest is 65. That is 100 minus 35. Say no for this question. Okay. And column totals is, for the first column it is 82, and the second column it should be 218. Okay. As a whole, if you add 82 plus 218, you get 300. Similarly, if you add 3 rows, you get 300 again. So row total and column total, sum of row totals and column totals should be same. That is the joint distribution or joint frequency table of two variables. That is, one variable is group, compensation makes for unique. Compensation makes for unique and compiling variable. Of course, this is a nominal data. Since claim is there is a significant difference among the business group, so our null hypothesis is there is no difference among the business group. There is a difference among the business group. This is our claim. Right? So the null hypothesis is there is no difference among the. Why? Phi 1 is a proportion of population proportion of case in group B. Phi 1 is a 5 is the population proportion of yes. Yeah. 5 is the population proportion of yes group. Since the claim is there is a difference among business group, this is our research hypothesis or alternative. Alternative. Okay. There is a multiple choice about alternative hypothesis, and there is the options phi 1 not equal to phi 2 because I observed that so many people choose these options or alternative hypothesis. But if you choose these options, this is absolutely incorrect. Why? Because this question doesn't consider that phi 1 equal to phi 2 not equal to phi. Similarly, phi 1 equal to pi 3 not equal to pi 2. Similarly, pi 1, pi 2 equal to pi 3 not equal to pi 1. This question doesn't consider. Choose the alternative hypothesis on this problem, pi 1 not equal to pi. Correct option is at least one of others. This is this point. So now, for testing this hypothesis, we use I-square test for homogeneity. For computing test of hypothesis, test statistics, for computing test statistics, first need to compute expected frequency. For expected frequency of Gaussian field, O0 O I naught O naught j divided by capital. What is O I naught? O I naught is a ith root of its example 100 O1 naught for first row. Since we use 100 individuals for each group, so O1 naught, O2 naught, O0 is all same. So OI naught is OI naught is OI naught is column total. Therefore, in the example, this is O01, O01, so this capital N, the total frequency. Okay. So, and these are O11, that is observed frequency of 11 cell, observed frequency of 21 cell, observed frequency of 31 cell. This is observed frequency of 1 cell, observed frequency of 2 cell, observed frequency of 2 cells. So, using this formula, we can easily compute the expected frequencies. Yes, no, it's going to be in chart E. So, O1 naught into for the first cell O1 naught, O naught 1. O1 naught means 100 into 001 means 82 divided by 300. Similarly, this is again O not again 100, O not 1 is 82 divided by 300. Because 100 individuals from so I have same this verification. Even before 1 to itself O1 naught into O naught 2, that is 218 divided by 300. O2 naught, that is 100 into O naught 2, that is 218 divided by 300. 100 into 218. Computing this part, okay, 152 by 300, we get color, get 27.6. Similarly, this is also 27.50. Similarly, this is also 13%. This is also 72.7. So we did this same frequency, expected cell frequency by EIG. So this could be 1 for the second cell, T1 for cell of first column, second cell of first row, divided by T1 is equal to 7. Now the got this value, we knew OIJ, AIJ, just using to get the value of transfer is equal to 17.7. Okay. So now the decrease of which stands for decrease of equal to number of rows minus 1. Here number of rows is 3, number of columns is 2. Here the level of significance is 0.0. level of significance. You can like Excel, or you can directly use I-square table. So for here I give you the output for finding critical value of I square. Suppose I want to round this value into two decimal place. So this will be 2 pi I square 0.5 into this, which is 4. We get the value. The value is 4.601. Hence, we observe that value of the statistical event inject 0.1. So, we reject of these two. So we conclude that there is a significant difference. There is a significant difference. There is a significant difference among the business group with respect to proportion that step makes for unique and company. So the conclusion is there is a significant difference among the, I repeat again, the conclusion, if you write the conclusions, there is a significant difference among the business group. Write the difference with respect to the proportions that they for it completely. But here I want to mention that we should also compute p-value. Why we should compute p-value? Because p-value gives you the strength of the rejection of null hypothesis. Critical value, based on critical value, we just reject the null hypothesis only, whether reject or accept. But p-value not only say whether you accept or reject the null hypothesis, also you can say the strength you can say about the strength of the rejection of the null hypothesis. So it is better you draw the conclusion based on critical value. We also compute, we need to compute p-value also. Okay. So for this, since it is a right tail case, because the value of test statistic is always positive, so it is a right tail case. So p value is probability of chi-square. This is the probability value chi-square, which is greater than observed value 756, where chi-square follow chi-square with 2 degrees of freedom. You can use R code, find R, Excel, Minitab. You can use any statistical package. You can easily get this p value. Here I just gave it, for example, I give the R code for how to compute p value. That is round 1 minus p square PCISQ of the statistics, degrees of freedom, and I want to round this value up to 3 decimal place. Just I write 3. If you want to 4, then you write 4 instead of 3. Just use this 4. Okay. So from the p value, why I am saying the strength of rejection of null hypothesis? Why? Because here I consider level of significance 0.10. Even if I consider level of significance 0.001, in that case also you reject null hypothesis. But from this critical value, you can only say it is rejected at the level 0.10. For rejecting the null hypothesis 0.01, you need to again compute critical value. If you again change the level, again you need to compute critical value, and every stage the level of significance, if you change the level of significance, you need to compute critical value again and again, and see whether the value of the test statistic is greater than critical value or not. But if you compute p value, then you can easily say, you can choose the level of significance, any level of significance, 0.001, 0.00, 0.01, 0.05, 0.025, whatever you can choose. You can easily check using p value whether you reject null hypothesis or not. So that's why p value gives you the strength of the rejections of null hypothesis. So it's very interesting. You should compute value also for testing of hypothesis. It's very important. So since the p value is 0.00, the level of significance is 0.10, since p value less than 0.10, check significant, you get the conclusion. Same decision. So that's all for today.